Morning. My name is Gary Picher. Thanks for coming to IBM Expert TV. I've had a couple of presentations in the past 2 weeks, so let me just kind of position this one so you know where it fits in. 2 weeks ago, I did a security hardening presentation, part one. This is the part two that follows on to that. You may have also seen my presentation 2 days ago on Monday, November 8th for IBM Community Festival. That was a condensed version of this in an hour where I did both parts but shortened it. So if you saw that one on 2 days ago, you probably have most of the material. This might be a little bit more of a deep dive. But if you did see the Expert TV session 2 weeks ago, that was a part one. This is the follow-on to that. So my name is Gary Picher. I work for IBM WebSphere Application Server. I've been doing that for almost 20 years. I work in the security area. And I'm going to talk about best practices for security hardening for production. One thing I want to note is that you can type questions for me that I'll be able to answer at the end of this. There's a little bit of a delay when you type the questions before I can see them. So if while I'm talking you have a question, go ahead, type it into chat. And then at the end of this, I'll go tab over and see if there's any questions and talk about them. Okay, let's get started. So the agenda. I'm going to briefly go over something I did in part one, which is the types of intrusions and vulnerabilities I'm addressing. And I'm going to break them into three areas: operating system, network, and application. So I'll explain what those are. If you're interested in more of a deep dive in the operating system and network areas, that was covered back in part one. Today in part two, I'm going to talk about the application security hardening. Okay, so a brief review. What types of intrusions and vulnerabilities are we trying to protect against? And here in WebSphere, we break it down into three groups: operating system, network, and application. Operating system hardening is about hardening the machine and local access on the machine that your Liberty server is running on. And so what this means is that if you have arbitrary users who have access to that machine, you want to make sure that they, well, ideally they shouldn't have access to that machine. But for those who do have access to the machine, you want to make sure they can't read sensitive information, edit the Liberty config unless they're specifically an admin. So it's sort of a file permission hardening of your Liberty binaries and your config files to make sure only admins and people who need access to edit and see Liberty files can do it. Again, that was deep dived in the part one. Network intrusions and vulnerabilities are people trying to intercept activity on the wire. So you might have a legitimate client on a browser. They're connecting to a remote Liberty application server, and maybe someone's in the middle trying to read that network traffic and either read something they're not supposed to or potentially insert some data into the network traffic to corrupt the flow, get access they're not supposed to have. And then finally, application security is more about making sure that people who connect to the application from a client, such as a browser, can't use the application in a way to elevate their privilege or expose a vulnerability. So this is different from intercepting network traffic. Application security is just about, hey, a legitimate user with a browser is establishing a straight connection to your Liberty server, and maybe they can access URLs they're not supposed to. So this is about hardening that area. Okay. Also, just to note, the first Expert TV session I did took a whole hour. This one is not. This is the third part, application security hardening. So I'm expecting it to be about 20-25 minutes or so, just so you know. Okay. Application security is primarily about understanding Java EE roles and mappings. So if you're running an application server, or I'm sorry, if you're running an application in a Liberty server, you're writing your application to the Java Enterprise Edition spec. And that spec defines the ability to secure your application with roles. And then it provides the ability, well, WebSphere Liberty provides the ability to map those roles to actual users or groups or special subjects in the target deployment environment. So let's break that down into two steps. First of all, protecting your application resources with roles. When you have an application, it's packaged in a WAR file, there's a web XML inside it. As part of your application development, you need to decide what endpoints you want to expose and who should have access to that. The problem is, if you're an application developer, you might not know the target deployment environment. It might be deployed in multiple target deployment environments. So as an application developer, you have to secure your resources with something called a role, which is something that you can sort of make up in a way. So let's say that in your application, you have 2 or 3 endpoints that you want people to access. Let's say one of those endpoints is an administrative endpoint, and one of those endpoints is a general user endpoint. You would secure your application by saying, hey, any URL that ends with a certain ending can only be accessed by people with the user role. And then you might have another endpoint, another URI that's only meant for administrators. And you would go secure that with the administrator role. And I'm going to go into more detail in future slides. This is just an overview. And so as an application developer, you're kind of implying that, hey, these resources are meant to be accessed by regular users, and these resources are meant to be accessed by administrators. But again, as an application developer, you don't know who those people are in the target deployment environment. So there needs to be a second step done by whoever's deploying the application, some sort of system administrator, where they have to say, hey, I need to map all of the roles that the application developer assigned to actual users or groups or special constants in the target deployment environment. And so the way this is done is that the application developer can define the roles either in their web XML or using annotations. And then whoever's responsible for deploying or administering the app, they can define bindings in the IBM application BND files or in server XML. And in those bindings, they take the list of roles defined by the application and they say, oh, okay, these URLs are meant to be accessed by users. So on this deployment environment, that means a certain group ABCD. And this set of URLs is supposed to be accessed by administrators. Okay, in this deployment environment, all the administrators are in the Liberty admin group, for example. So there's a distinction between the application developer who's defining the roles and sort of giving a general idea of who should have access to it, and then the deployment environment where you're actually saying, hey, these are the actual groups in the target deployment environment who are associated with these roles. So let me break this down a little bit. This is an example of defining a role in your web XML. So in this example here, what we've done is we defined a web resource collection. We've named it, which is optional. And we've said this web resource collection applies to the URL pattern /myservlet. So what the URL pattern is, it's the portion of the URL that comes after the protocol, the host, and the port. So if your server is located at https www.ibmexample.com, everything that comes after that /myservlet, that's what the URL pattern is implying. So if you look at the second bullet in this chart, if you define a URL pattern of /myservlet and it's running in www.ibm.example.com, then this is the URL in the second bullet that will be protected by this web resource definition. Okay. After we've defined the web resource collection, we go on to define an auth constraint. And in the auth constraint, we've said, okay, this web resource collection is restricted to people with the A role name. So in this example, we've said any resource with a URL pattern of /myservlet can only be invoked by an authenticated user who has the A role. Now, one thing to point out here is I say authenticated user. When a browser tries to access a protected endpoint of the Liberty application server, the authentication flow will be kicked off by Liberty under the covers. And that's dependent on how the administrator has configured the authentication, normally to an LDAP registry. So when you first hit a protected resource, Liberty runs the authentication flow and figures out who you are. But then we have to figure out, okay, now that we know who you are you associated with this role? Now, one thing to point out is with the URL pattern in this example, there are no wildcards. I just specified a URL pattern of /myservlet. That means that if you have something after /myservlet, like /myservlet / something else, that's not protected by this role. But you can use wildcards. So I could have said /myservlet* in the URL pattern, and that would protect both /myservlet and /myservlet / something else or whatever else. Now, another example here is how you can define roles with annotations. So annotations are defined right in the application Java source code. So in this example here, this is the same security constraint that I showed on the previous slide, but defining it in the Java source code itself. So you have the web servlet annotation, which says, hey, this class right here is served at the /myservlet URI, and it's constrained to the HTTP constraint roles allowed equals a role. This does the same thing as the previous slide did, but it's right in the application source code. One difference to be aware of is that you can only protect servlets with annotations. If you go back to the web XML, you can protect any URL pattern, whether it's static content or servlets or JSPs or anything. They can be protected in web XML. Anything with a URL pattern can be protected there. It doesn't matter what it is. But if you want to use annotations, you can only protect servlets. Okay, so now that the application has defined some roles, defined some URL patterns, and said, hey, these URL patterns can only be accessed by people with this role, we have to do a mapping. It's not mandatory to do a mapping. And in a future slide, I will talk about the downfalls of if you don't do a mapping. But at this point, let me say it's highly recommended that you have a mapping of your application roles to groups in the target deployment environment. You can do this. It's the same XML syntax in either case. You can put it in your IBM application BND files or in server XML. So if you notice in the two examples here, they're separated with an or. The sample XML here is exactly the same. And all it does is it says, hey, the security role name of a role is actually, in this target deployment environment, actually means anyone in the group name of operators. So now what happens is when your client connects to your server and you hit a protected URL, Liberty runs its authentication flow and says, hey, I know who this user is. Let's say the username is Gary. And then it says, okay, the URL that Gary's trying to access is protected. So the only people who can access this URL are people with the A role. So now we have to figure out, okay, does Gary have the A role? And so then the runtime says, well, the A role in the application is actually bound to the group called operators. So if Gary is in the group called operators, then Gary qualifies as having a role and is able to invoke that URL pattern. So now some catches. So here's the default behavior I talked about before. If you don't map roles in either IBM application BND or server XML, then any roles that are specified in the application are treated as literal group names. So going back to the previous example, if the application defined a URL pattern and said, hey, only people with the role a role can access this URL pattern, and if nobody actually maps a role to a group in the target deployment environment, the default behavior is we'll actually look for a group called a role in the target deployment environment, and if that group happens to exist and the authenticated user is a member of that group, they will be able to invoke that URL pattern. That can lead to some unexpected behavior, especially if the roles defined in the application are pretty generically named. So it's strongly recommended that you do role mappings for all the roles in your application. Another thing to be aware of is any URL patterns that are not specifically protected by a role, either with an annotation or a web XML, are unprotected. This means that you have to explicitly go in and define rules for every endpoint that you want to protect. There's a way around that, which I'll get to, but that's the default behavior. Other things to be aware of: if there's a conflict with the security constraint definitions in web XML or via an annotation, the web XML takes precedence. Similarly, if there's a conflict with mapping roles to groups in your IBM application BND or server XML, then server XML will take precedence. So these are all default behaviors to be aware of. And now I want to move into a best practice. So I've already said one of the best practices is make sure you always map your roles to groups in the target deployment environment. Another best practice is for your application to add a rule that denies by default. So previously I said if you don't specify an endpoint, a URL pattern in your web XML, the default behavior of the spec is to say, hey, if it's not specified there, it's unprotected. But you can add a rule. So if you look over here on the left, this rule will work with any level of the servlet specification. You can add a security constraint with a URL pattern of /star, which matches every URL pattern that can exist. And then you can leave an empty auth constraint. If you do that, then if this is a rule in your web XML, then what that says is, hey, right now, if this is the only thing in your web XML, everything is now protected. Any endpoint that matches /star, which is all of them, has no roles associated with it, so nobody can execute it. This is a very good thing. If you're running Servlet 3.1 or later, which most folks probably are by now, you can look over on the right of this slide, and there's a simpler way to do this. There's the deny uncovered HTTP methods element. You can add that into your web XML, and it does the same thing. So both of the bits of XML you see in this slide do the exact same thing. The one on the left will add a deny all rule for any level of the servlet spec. The one on the right will add a deny all rule for Servlet 3.1 or later. So I would strongly recommend that all of your applications add one of these to the beginning of the web XML so that everything is protected by default. And then you would go on after that to delineate the specific endpoints you want to expose and the specific roles those are associated with. However, there's a warning here. If you do this and your application developers update the application and add a new endpoint, and they expect that endpoint to be immediately accessible, they're going to be upset because this is the whole point. We've added this deny by default rule, and that means that if there are new endpoints that you're intending to expose, you need to go into this web XML and specifically add a rule to say, hey, here's a new endpoint we're going to secure, and here's the role it's associated with. Again, this is exactly the point from a security perspective, but it's something for developers and deployers to be aware of because it does add an extra step when they want to add a new endpoint. Here's an example. This is not a best practice, but this is an example of something you can do if you've added that deny all rule and you have something that everybody needs to access, like a form login. So just going over this a bit, if you never added the deny all rule that I talked about in the previous slide, then you'd be able to access all the endpoints in your application unless they're explicitly guarded by a rule. But once you add that deny all rule, now you have to add explicit rules for all your endpoints. But for something like a form login where the user hasn't even logged in yet, that needs to be accessible to everybody. So this is an example of if you have a form login and if you have already defined a deny all rule and you want to say, hey, but now I want to grant everybody access to the form login, you can do it with this method. So over on the left in your web XML, we defined a security constraint. We've specified that any URL pattern that's exactly /login JSP or anything in the images directory or anything in the CSS directory, and only when it's called with the HTTP GET method. For that, anything that fits that pattern will be accessible by anybody with the all users role name. Now, does that mean anything? Well, not quite yet. But at runtime, what we can do is over on the right in your application BND or server XML, you can map that security role of all users to something called a special subject with the type of everyone. And what that basically says is the all users role really means everyone. Anyone who pings the server will be able to access these URL patterns. There are also other special subjects like all authenticated users. And what that means is that if someone tries to access one of these URL patterns, Liberty will run the authentication flow. But as long as you're able to log in as anybody, you can access this pattern. Now, that wouldn't be appropriate for a form login, but you might have some resources in your application that anyone who can log into the server should be able to access. That would be where you would use the special subject type all authenticated users. All right, so having covered the basics of Java EE roles and mappings, let me get to some recommendations that are specific to Liberty here. The first one is don't serve servlets by class name. So let me explain what that is. In all the previous slides, I've talked about defining servlets by their URL pattern. There's also an ability in Liberty. We have a property called serve servlets by class name enabled. And if you set that to true, we will allow you to go to your browser in your URL bar, type the host name and port, and then type /servlet, and then the fully qualified package and class name of any servlet in the application. And if this property is set to true, we will allow you to access that servlet as long as you know the fully qualified package and class name. The problem is this bypasses the protection that we've added in the previous files, like the web XML, where we've protected all these servlet aliases. So the basic recommendation here is don't use this feature. If you encounter this feature and it looks convenient, maybe for a development environment, fine. But this is not a production feature. Disable this, as it does introduce a security hole. Another suggestion here, don't place sensitive information in the root of your WAR file. WAR files contain, by default, servable content, or by definition, I should say, servable content. So any files found in the root of the WAR file are potentially servable if someone knows the URL to access it. So you should never place content that shouldn't be shown to users in the root of the WAR file. There is a place that the specification defines. It's the webinf directory. If you put things like class files or sensitive information in the webinf directory, the servlet specification prevents it from being served. So that's a safe place to put it, but don't put sensitive information in the WAR root. Next recommendation, define a default error handler. So by default, if a user is accessing your application and something happens, even if it's an application bug, an exception or something, the default behavior of Liberty is to send back an error page that includes some diagnostic information, potentially even a stack trace of whatever the problem was. This is one of those features that's great for developers, but it's terrible in production. For developers, it's very handy to, hey, see the stack trace right in the browser if there's a problem. But in production, not only is that ugly to a typical user, but to a hacker, that provides valuable information about class structure. So for example, let's say we go back to the previous slide and you had the serve servlets by class name property enabled. And then let's say you didn't define a default error handler. A hacker might be able to use your application, force some kind of error, see the stack trace in their browser, discover the fully qualified class name of your servlet, and then go invoke it by class name. So this is something I talked about in the first part of this presentation about stacking multiple defenses against the same type of attack. You never know. You want to be careful. If a hacker is able to bypass one level if a hacker is able to take advantage of one vulnerability, you want to limit what they can do with that to take advantage of further vulnerabilities. So by restricting the information a hacker can find out, you make it harder for them to find ways to attack your server. But still, even though you've overridden the default error handler, you still want to take other mitigation measures like preventing serving servlets by class name to begin with. So by doing multiple of these steps, we put multiple barriers in front of hackers who are trying to attack you. This follows on from providing your own error page. There are also these properties you can set in your server XML to disable other ways that someone with a browser can discover what the runtime is. So similar to what I said earlier, if a hacker goes in and uses your application and causes an error and sees the stack trace, they can discover internal workings of your application. But similarly, a hacker can invoke the application and look at the HTTP headers that come back and maybe find out things like, oh, this application is running in Liberty, and maybe even find out the version or the JDK version. And so the set of properties here on this slide remove all that information. So we've disabled the welcome page. This by default is encountered if you just go to the host with a slash. So we want to disable that completely because that does say, hey, this is Liberty. We also want to remove server headers and the X powered by header. Both of those are intended to be informational, to just give you information about the runtime, but can be abused by a hacker. So in a production environment, you want to disable all this information. I talked about this a bit in part one of this talk, but you want to ensure as much as possible that your application uses encryption, so TLS or SSL. If your application has some legacy need to serve content over an HTTP port, a non-encrypted port, you probably want to look into why that is and see if you can re-architect the application. If you have static content, you might want to move that into the IBM HTTP server or your Nginx server or the HTTP server that's front-ending the application server. Move your static content, anything that needs to be accessible over HTTP there. And if you can get your application to the point where all of the content is meant to be accessed over SSL, what you can actually do is go into your server XML and disable all of the non-SSL ports. Again, there are multiple ways to enforce SSL, and this goes back to stacking barriers in front of hackers. So this is one way to enforce the use of SSL, is disabling all of your non-SSL ports. The downside of this is that there may be legacy applications or legacy reasons for someone to access your server over non-SSL. That shouldn't be the case, but if it is, you can't do this. But it's a good idea if you can. Another thing you want to be careful of is securing cookies. Liberty has a couple of sensitive cookies. One of them is JSession ID. One of them is the LTPA token cookie. The JSession ID cookie contains information about your session. So when your browser talks to the application server and it goes back and forth and back and forth, there's session data maintained over on the server side, so that when the browser goes back to the server a second time, it remembers what you were doing. For example, what was in your shopping cart. The cookie that connects that session to the browser is called JSession ID. However, if that JSession ID was sent over a non-SSL connection, it's possible for someone in the middle to intercept that network traffic, steal your JSession ID cookie, and then maybe try to replay a request over to the server. The hacker could connect directly to the server and try to pass your JSession ID and access your session. So to avoid that, we can set this property here in the second bullet to say HTTP session cookie secure equals true, which means that the server will only send the JSession ID cookie back to the browser if it's over an SSL connection, an HTTPS connection. Similarly, the LTPA token is IBM's proprietary single sign-on token. Like any single sign-on token, that needs to be protected. And so by specifying web app security, SSO requires SSL equals true. That tells the Liberty server only send the LTPA token cookie when it's over an SSL connection. A couple other thoughts here. Disable file serving and directory browsing. And we show you here right in the first bullet. What that is if you've ever used your browser to connect to a website and you you see a directory listing, like it's contents of the file system, and you're able to browse around by clicking the dot or browsing through directories. That's what directory browsing is within your application. There's very little reason to allow someone to do that. It's for the most part, it can only expose security problems. So you want to disable that if you can. If you have some static content in your WAR file that needs to be servable, you do have to leave file serving enabled. But like I talked about before, you want to probably move your static content out into your HTTP server and keep your application server serving dynamic content. So as long as your application holds to that, you can just disable the directory browsing entirely. The second bullet here talks about specifying a transport guarantee. So this is in WebXML. This is inside your security constraints. You can specify a user data constraint called transport guarantee confidential. And what this means is that for whatever endpoint you're specifying a transport guarantee of confidential for, that endpoint can only be accessed over SSL. So again, this is an example of stacking various barriers. This is an application way of saying, hey, this application, these URL patterns can only be accessed over SSL. In addition to what I mentioned earlier about, hey, maybe you just want to turn off your non-SSL ports entirely if you can. So these are multiple ways to enforce the same best practice. That's it. It's like I said, it might be about a half hour. There are some white papers with a whole lot more detailed information. You can follow the link on this slide. And I'd encourage everyone, the white paper is probably 70, 80 pages long. There are 2 of them. That contains all the information I've discussed in both of these sessions in a lot more detail, and it gives you detailed instructions on how to implement some of this stuff. So it's worth checking out. And that's the end of today's presentation. And if you have any questions, I'll take some time to answer them. Looks like there are no questions so far. So what I'll do is I'll hang out for 30 seconds or so. If anyone has a question, you can type it in. Otherwise, you can have a nice day. Okay, I don't see any questions popping up. So what I will do is just mention if you get these slides and go to the first one, my email address is on the first. I do have a question. I'll get to it in a second. Okay, so I'll just read the question. So anyway, back to my first slide. My email address is on the first slide. Feel free to send me an email at any point if you have a question. I'd be happy to answer that. Why not set defaults to true when securing cookies? So the question is referring to, let me go back to this slide. It's a good question. Why not set the default? The Liberty, the way the Liberty design philosophy is, we don't change defaults. So Liberty is probably about 8 years old now. As a general rule, we want to support backwards compatibility. So I don't have a historical answer to why the defaults are false sometimes, but it is a best practice now to set it to true. And if we changed it in service, we could break backwards compatibility. So I don't know the original answer to your question, but as a general rule, sometimes there's an old setting that we just can't change to not break customers, even though a couple of years later we realized that, hey, this is really a best practice we should be telling customers to set. I think I can't think of a realistic use case where you would want to set these defaults. Okay, let me wait a little bit longer, see if there are more questions. Okay, that's all the questions we have. So thank you very much for attending and have a good rest of your day. Thank you and take care.